Okay, so notes 5 is over heirs and power. So before we describe the heirs and what a power is, we're going to look at an analogy, and this is the courtroom analogy. Okay, so when you're in a courtroom, you have the person that is on trial, okay, and then you have the judge, and then you have the jury, okay. In this table, it's showing us 2 columns for truth. So this is the person on trial. That person could either be guilty or not guilty. And then we have the jury's decision, again, which could be guilty or not guilty. So if we look at this table, let's say the jury says that the individual is guilty, even though they're not guilty. What is happening to this person? They're what? Falsely accused. That means, where are they going? Jail. And what type of person are they? Innocent. So that means an innocent person is going to jail. Good or bad? Bad. Okay, now let's say we have the opposite. We have a person who is guilty, but the jury said not guilty. So what's happening? Good. The guilty person is free. Okay. And then we have the 2 other columns, and notice in these columns, both of these are correct decisions. So we have the individual is guilty, and the jury said they're guilty. So this is correct. Okay. Versus the person is not guilty, but then the jury said they're not guilty. So this is also correct. Okay. So for the next minute, I want you within your groups to answer that question. What would be considered the worst mistake? An innocent person goes to jail or a guilty person is free? Okay, take a minute, and then I'm going to call in some groups.
If you're crazy enough to be a fucking murderer.
Language. I'm recording.
I'm recording.
So I think it's kind of 50. That's 3 lives over 1. I mean,
Yes. Oh, I thought you were asking me a question. Okay. What are my thoughts? You're going to hear my thoughts in just a moment. Okay, let's start with group 1. Group 1, what would you consider to be the worst mistake?
We said the innocent person going to jail.
Okay, the innocent person going to jail. Why?
Because the guilty person being free. There's a whole range of crimes on like what they could have done. It could have been something really minor.
Mm-hmm.
So them going free, like, and in some cases that wouldn't even really be a problem if they're not really a danger to other people. But meanwhile, the innocent person going to jail, they're always going to go to jail no matter what people think they did.
Good, good. Okay, so let's see. Group 2, what's your decision on the worst mistake? Okay, 50-50, you couldn't decide.
Yeah, we both have great arguments about it.
Okay, give me one argument for the guilty person is free being the worst mistake.
If they're a mass murderer, they can continue murdering or something.
Good, if they're a mass murderer, they could continue killing people. Yes. Okay, let's see, group 7. What do you consider the worst mistake? The guilty person is free?
Yes.
And what's your reasoning? Okay, so if the crime is murder, right, then they could still. Okay, so what I'm hearing is, does everyone in this room agree which one the worst mistake is?
Yes.
No, not everyone agrees. Okay, And what that means is that it depends. Okay? It depends. So what if I told you instead the crime was shoplifting? Would that change your decision?
Neither are bad.
No.
Well, that's your opinion. Would it change your opinion within your group? If it was shoplifting, would you say an innocent person going to jail is worse than a guilty person being free? Uh-huh.
Like a company rather than like a small mom and pop shop.
Wait, why is shoplifting in court? This is not, this is too much.
This is make-believe, okay? It's just pretend.
You're on your right.
Okay, what if I change it and say the crime is a serial killer?
No,
Well, then obviously
God,
the
definitely
guilty person being free is horrible.
but then
But
again,
what
for a
about the
person-
innocent
for an
person in
innocent
jail? They
person,
just got
they can't
accused
do
of being a serial killer. Their life is over.
I mean, well, that is a serial killer losing.
They can be put innocent later.
Like, you can die.
But there's-
Oh, that's a good one. What if the punishment was death penalty?
Oh,
Why are
then the
Seriously
guilty.
wrong.
Yeah, and the innocent person goes to jail.
So then it would be the innocent person, right?
No? 'Cause
No?
Because then they can get
crime would be worse if it was a death penalty.
If the crime would be worse. But then we're setting an innocent person to their death. But then we're also releasing a guilty person to continue
Well-
with their crimes.
With the guilty, they would at least do it again, so you can try to get them again.
But if you send an innocent person to jail, and let's say they have a retrial and they were proven innocent, their credibility is gone,
Yeah.
right?
They can't get a job.
So there's no right or wrong answer here, right? So what that means is that in order to just consider what is the worst mistake, it's going to depend on the situation. That was a good discussion, right? Depends on the situation. So in this case, it's going to be the type of crime. Okay. So in this analogy, us, the statisticians in this class, is the jury. Okay? We are all the jury. Which means before we can start an experiment, a simulation, whatever we're doing, we need to be able to consider what the worst mistake is. Okay? That is going to help us identify what possible errors can occur in our when we're collecting our data and conducting our tests. Okay, so we need to decide the worst mistake before conducting a test. Okay, so if we go back to our courtroom analogy, right? These people in the jury already know the person's crime. Okay, so they already know what type of crime it is. And they need to make the decision when they are saying if this person is guilty or not guilty, whether or not a mistake could happen. Yes, whether or not that mistake that happens is going to be worst for the individual or worst for the society. Okay. So again, if we, the statisticians, are the jury, it says a jury is going to decide whether the defendant is guilty or not guilty. That is the same as us deciding whether we are going to reject or fail to reject which hypothesis? The null hypothesis. Okay, so a jury deciding guilty or not guilty is the same as us deciding whether we're going to reject or fail to reject the null hypothesis. Okay. We always start with the assumption that the defendant is innocent unless proven guilty. So we always assume that the null hypothesis is true unless we can provide convincing evidence against it. So we assume the null hypothesis is true. That's why when we write the null hypothesis, we always have P equals. And then lastly, it says a court presents evidence and then a decision is made. So for us, that's us finding a p-value. So calculating that p-value. Okay. And then deciding if comparing that p-value to alpha, if we have enough evidence or not enough evidence to in favor of the alternative hypothesis. So that's finding the p-value, comparing it to alpha, and seeing if we have enough convincing evidence. Okay, so now we're going to take the table that we just did with the courtroom analogy, and we are going to create our own table based off of the truth about the population. Okay, so whatever that population may be, and then our decision as the statisticians. Okay, so for the truth, there are two possible. You can either fail to reject the null hypothesis, or you can reject the null hypothesis. Which means if we're talking about the population, when we run our experiment or our test, we should come to the truth of either failing to reject or the truth of rejecting. Okay? Our decision is the same. We can either choose to reject the null hypothesis or fail to reject the null hypothesis. Okay? When the truth matches our decision, we say that is correct. Okay? So when the truth matches our decision, we say that's correct. Okay, so if we were supposed to reject it and we did reject it, we're good, and vice versa. Okay, however, if we reject the null hypothesis when we were supposed to fail to reject the null hypothesis, this is called a type 1 error. And if we do the opposite, if we fail to reject the null hypothesis when we were supposed to reject the null hypothesis, this is called a type 2 error. Okay. Within the two correct responses, one of the correct response has a special name, and that is if we reject the null hypothesis correctly. That is called a power. Okay. So if we reject the null hypothesis when we were supposed to reject the null hypothesis, that says we have a power. Okay. Any questions about this table before we move on? Okay, so now we're going to look at another example. In this example, we have our hypothesis statement. You are not pregnant. That is our null hypothesis. And then you are pregnant. That is our alternative hypothesis. So it says when you go into a doctor's office, it is always assumed you are not pregnant until they get tests to tell them otherwise. So looking at this diagram, okay, which two are the correct decision? Which two is the correct?
The old man not being pregnant and the woman being pregnant.
Good. The old man not being pregnant and the pregnant woman saying they're pregnant. Okay, right? Those are both good doctors. They're making correct decisions. Okay, so I'm going to write correct and correct. Okay, and we know that they're correct because their truth and their decision is what? We know they're correct because their truth and their decision are the same. So for the first one, where the doctor is telling the woman that she is pregnant, the truth is that she is pregnant. So you are pregnant, which again is our alternative hypothesis, our HA. That's what we mentioned at the top. And then the decision, this is the doctor's decision saying you are pregnant. Okay, the decisions are the same, and they both came from the alternative hypothesis. This correct one, okay, is telling us that not only is it a correct decision, it is a correct decision with the special name power. Okay, the one on the bottom, does that one have a special name? No, it's not special enough, right? It's just called correct. And for this one to be correct, that means that the truth and decision have to be the same, right? The truth is you're not pregnant because it's an old man. And remember, this saying that you are not pregnant is the null hypothesis, so this is H not. And then the decision of the doctor is you are not pregnant. Okay, then we have our two errors here. Okay, looking at this first one, what is the error?
He's not pregnant and he was told he was pregnant.
Good, he's not pregnant, even though the doctor told him he is pregnant. Would you want this to be your doctor? No. So the truth is that this old man is not pregnant, so we would say you are not pregnant, which is the null hypothesis, and the doctor decided what? You are pregnant. I was thinking the same, like, that guy is probably stressing out so much. Like, what do you mean?
He would be stressing out. Like,
Okay, but do you imagine, like, a doctor is someone in authority, right? They went to school for all these years to be able to become a doctor. Right off the bat, I would be like, either, what do you mean you must be right, or what do you mean you learn nothing in school?
But it's like, I think there was, I guess also he goes like, if a guy takes a pregnancy test and it's positive.
Yes.
And then it's wrong with him.
Yes, so if a guy takes a pregnancy test and you get a positive result, that means you have prostate cancer. Okay, however, yes, that is true. So if a guy takes a pregnancy test and it's positive, you have prostate cancer. However, if that was true, would the doctor go up to this guy and say, you are pregnant?
What if he's like
No,
a
he'd be
silly
like,
funny
boy,
guy? You're pregnant.
I don't want a silly, funny guy as my doctor. I want a serious person.
Put the truth is he has cancer.
But the truth is he has cancer, right? He wouldn't say, you are pregnant. He would be like, I'm so sorry, you have prostate cancer.
Make sure you have cancer.
and then be like,
Okay.
Just kidding, you got cancer.
Give me a
It's the best way to
Okay, what type of error is this? Type 1. Because we're all writing type 1 error. Yeah. Okay. Good. And then we have this one right here. Okay, you go in, you're a woman, you're clearly pregnant, and then the doctor comes up to you and says, you're not pregnant. You're not pregnant. Even though you're like, but doctor, I feel kicks. Like, I'm sure I'm pregnant. No, you're crazy. You're not pregnant.
you want to
It's such a large tumor.
Yeah.
She thought she was pregnant with Jesus.
What?
Okay, so the truth is you are pregnant.
She genuinely thought she had baby Jesus in her stomach. She was literally so crazy.
Which is the alternative hypothesis. And then what was the doctor's decision?
Tell her she's not pregnant.
You aren't pregnant. Way to break her heart. Or make her happy. I don't know what her situation is.
Look pregnant. I don't know what you're talking about.
Right, we can never assume, right? We can't assume.
That's a flat belly from what I said.
But she is holding her belly like this, right?
Well,
That's
she's
she just ate. She has a tummy ache. Oh my gosh. Okay, so this is a type 2 error. So, looking at these two types of errors within your group, discuss which one is the worst mistake.
Honestly,
Which one is the worst mistake? So take a minute, discuss.
If you're a man and you ask
What if she's like, what if she saying like you're not pregnant? That's like shut. That would be sad.
As what?
Like you're not pregnant anymore. Things that. Like,
Oh, but that's not part of the statement, so we can't assume.
you're not
no,
pregnant.
wait, we don't know that.
It could just be the baby is dead already. Yeah. But like, okay, how did the doctor?
Wait, does the cancer, like, is the cancer part of this?
No.
So it's
No, don't make assumptions. Don't assume the guy has cancer. Don't assume anything about the baby.
How did he test it? Or is he just like no?
All I know is, I think
Just think, if you were in these people's shoes,
if I was a
okay, and the doctor is telling you this, which one would you think would be the worst mistake? Because something has to happen from it. Consequences happen from these mistakes.
the man will laugh.
the man is
Okay, so the man could laugh and be like, haha, you're funny,
You're joking.
or you're joking, right? But what about the woman?
She could go home and cry because she thought she was pregnant and stuff. Like, growing up.
Okay, she could do even worse than that, because crying won't hurt the baby.
Oh yeah, she'll go drink.
She can go have a drink. Doctor's like, I'm not pregnant. Here's my glass of wine. You can eat sushi pregnant.
So you can.
It can't be wrong.
she can take
I mean, you can. Okay, that's a myth. You can, as long as you're not eating like gas station sushi, right?
Go eat gas station sushi. You don't know.
Okay, she could go eat gas station sushi, right? That's gonna hurt the baby. Give her what is it, listeria?
Roller coaster.
Cocaine.
She could go on a roller coaster. She could do drugs,
Aggressive drugs.
aggressive drugs.
She lost her baby.
becomes a meth addict.
She's gonna jump down a flight of stairs.
Of course, most definitely happening.
So all of that is not just affecting her, it's affecting the baby. So what's the worst mistake?
Type 2.
The type 2, right? The type 2. The guy's just gonna be like, haha, this doctor is not smart. I'm gonna go get a different doctor, right? The woman could, maybe she takes the word for the doctor even though she has that big old belly and feeling kicks and everything. And she's just like, well, if the doctor says, and then goes through crazy things that hurt the baby.
Oh yeah, she could gain depression because she thought she lost the baby.
Like what's he saying?
Yeah.
She wasn't pregnant.
And now everyone's confused.
Okay, you guys are thinking too much, right? It's just an analogy, right? You're just thinking too much into it. But that was fun. Great discussions. Okay. Now let's go back to the definitions of these errors, and I'm going to give you some formulas. Okay, you guys ready? Yes. New year, new you. Yes. Okay, so type 1 error means that we reject the null hypothesis incorrectly, which means we should have done what? We should have failed to reject it. Okay. The probability of a type 1 error is equal to the significance level. And remember, we gave a variable to the significance level, and that is what? Alpha. So the probability of a type 1 error is equal to alpha. Okay. Our significance level tells us what p-value is low enough. Okay, what p-value is low enough. A type 2 error means that we fail to reject the null hypothesis incorrectly. That means we should have done what? We should have rejected the null hypothesis. We did that incorrectly. So the probability of a type 2 error is beta. Okay, so we have probability of type 1, which is alpha. We know alpha is the significance level. The probability of a type 2 error is beta. Then we have power. Power means that we reject the null hypothesis correctly. Okay, remember, power is one of our correct decisions. Okay, so we correctly rejected the null hypothesis when we were supposed to reject the null hypothesis. The probability we reject the null correctly is 1 minus the probability we reject the null incorrectly, which means the formula for power is equal to 1 minus beta. So we give you these formulas for probability of type 2 error and the power just to show you that they do have things associated with it. However, the most out of these errors that is tested on is this first one here. Okay, this is the most tested. Okay, especially when talking about probability of a type 1 error, which is alpha. Okay, not saying you don't need to know what a type 2 error and power is, but you don't necessarily need to know the formulas. You just need to know how to interpret them into a sentence. Okay, any questions so far? Okay, so errors and their relationships. So a type 1 and type 2 error have an indirect relationship. What does that mean by indirect? So they're opposite, right? If one does something, the other does the opposite. If one increases, the other decreases. If one decreases, the other increases. Our type 1 error is set with our significance level, okay, which we know is alpha. The higher alpha is, the lower our probability of failing to reject becomes. So our probability of failing to reject becomes. So our higher our alpha, the lower our probability of failing to reject. Okay. Which is why alpha and beta have an indirect relationship. Okay, type 1 versus type 2. The higher our alpha, the more likely we will reject the null. So reject the null hypothesis, which increases the likelihood we do that incorrectly, just as it increases the likelihood that we do it correctly. Okay, which means that a type 1 error and power have a direct relationship. So as the probability of the type 1 error increases, the higher the power of the test. So out of all of these relationships, the first one and the last one are the most important because it's talking about an indirect versus a direct relationship. Okay, last part of the notes talks about interpreting errors. So it says, what type of error would you rather have? And it says that depends on the problem. Okay, so that was us deciding what is the worst mistake. Which error would we rather have? For some tests, we want a low type 1, but for others, we want a low type 2. Okay, being able to interpret these is key on the AP exam, which means that you will have a lot of multiple choice questions where they will give you a scenario and you're going to have to say, is this type 1 or is this type 2? So here's an example. It says a drug manufacturer claims that less than 10% of patients who take its new drug for treating gestational diabetes will experience nausea. To test this claim, researchers conduct an experiment at the 5% significance level. Okay, so this is saying that someone in that manufacturer is claiming that it's going to be less than 10%. So if we need to create our null and alternative hypothesis, this sentence right here is telling us which one, the null or the alternative. Okay, it's alternative. Why is it not null?
Because it's saying it's
Yes, and null always has to be what? Equal to, because we're assuming the null hypothesis is true. So for our null hypothesis and our alternative hypothesis, we're saying P is equal to 0.10. And then for our alternative, it's going to be P is less than 0.10. Okay. So in order to determine what a type 1 and type 2 error is, what I suggest is you try to memorize this table. I'm going to give you a little table as a shortcut. So we have the truth, and we have the decision. So in our truths, we have H0 and HA. And then our decision, same thing, HA, H0. Okay. Remember, if we make the decision for the alternative when we should have done that for the null, that is a type 1 error. Okay. If we make the decision for the null hypothesis, okay, that means we failed to reject, even though we should have done this in favor of the alternative, which means reject, that is a type 2 error. Okay. And this top corner is called a what? Power. Okay, so this is to help us remember what is a type 1 and what is a type 2. So for part B, it says describe a type 1 and describe a type 2 error, and then explain the consequences of each. Okay, so just like we did in the doctor analogy above. Okay, so starting with type 1. Okay. Remember, type 1 is claiming HA when we should have claimed H0. So this is, we say less than 10% of patients experience nausea when really they don't. Okay, which means we're saying that these patients actually probably experience more than 10%. More than 10% of them will experience nausea. But we're saying only less than 10% of them do, even though when we should have said the opposite. So what that means is now we have to write our consequence. So if the manufacturer thinks that less than 10% of patients experience nausea, are they going to go fix their medication? No. So the consequence is that the manufacturer won't fix the meds, okay, because they think it's okay. So if they don't fix the meds, then what's happening to these patients? They're going to still experience a great deal of nausea. So the patients okay, so if we're looking at the perspective of the manufacturer, okay, not as the patient, as the manufacturer, would we be okay with the type 1 error? As a manufacturer, yes. We would be okay with a type 1 error because if we don't need to go fix the medicine, that means we're saving lots of money. And it's a company. They want to save money. Okay, if we were the patient, would we be okay with a type 1 error? No, because that means we are we are getting necessary, whatever the word is, nausea. Like they could have prevented this. That's what I'm trying to say. They could have prevented it and make sure you're not nauseous. And if you've ever been nauseous, it's the worst feeling in the world. So I would prefer they go back and fix it, right? So you don't experience it. So that is type 1. So now we have type 2. And type 2 is the opposite. So we say 10% of patients experience nausea when really less of them do. So the consequence is that the manufacturer is spending more money to fix the medicine that doesn't need it. Okay, I know the bell's about to ring, but I'm going to keep going because I'm recording. Okay. So part C says the test has a power of 0.54 to detect that the alternative is true. Explain what the power means in the setting and what is one way we can increase power. Well, we know power is directly proportional with alpha. So this is saying the probability we find less than 10% of patients with nausea correctly is 0.54. Okay. We can increase, bye guys, have a great day. We can increase power by increasing alpha. Okay. So it says you know that the power of this test at the 5% significance level against the alternative is 0.54. If you decide to use alpha is equal to 0.01 instead of 0.05, with no other changes to the test, will the power increase or decrease? So since they are directly proportional, power will decrease since the probability of alpha, because since alpha decreases.